Of Unit 10. Unit 10 is all about square root expressions and equations. In this video, we're going to talk about learning target 10a, which is the Pythagorean Theorem. By the end of this lesson, you will be able to use the Pythagorean Theorem to find the missing side of a right triangle. So as a little refresher, a right triangle is a triangle where one of the angles is 90 degrees. The two sides that are forming the 90-degree angle are called the legs of the triangle, and the side opposite the 90-degree angle is called the hypotenuse. And the hypotenuse is also the longest side in a right triangle. What the Pythagorean theorem tells us is if I'm given 2 out of 3 of the sides, I can use the Pythagorean theorem to find the third missing side. So here side A is this vertical length, side B is this horizontal length at the bottom, and side C is our hypotenuse length. So these are lengths of the triangle, not angles. What the Pythagorean theorem tells me is that if I take the two legs, so a squared plus b squared equals the hypotenuse squared, or c squared. So the sum of the square of the legs is equal to the hypotenuse squared. And it doesn't actually matter which side we call A and which side we call B, but we do have to make sure we're being careful and identifying which one is our hypotenuse, because that will make a difference. Let's go through some examples. So in all these examples, it says solve for the missing side of the triangle. And in this first example, we have a right triangle shown. We can tell that we have a 90-degree angle here. The 90-degree angle is denoted with this little square in the corner. And we have a vertical side with length 6, a horizontal side with length 7, and a question mark across this diagonal side. Which one of these is the hypotenuse? So the hypotenuse is actually the side that we're missing. So 6 and 7 are the lengths of our two legs. So I'm going to call 6a and I'm going to call 7b just to help us reference it back to the Pythagorean theorem. And our hypotenuse is what we are looking for. So using the Pythagorean theorem of a squared plus b squared equals c squared, we can substitute in these values. So in place of a, I'm going to substitute in 6. So we have 6 squared in the equation, plus in place of b, we're going to substitute in 7. So we have 7 squared is going to equal our c squared. Our goal is to now solve this equation for the value c. So as we simplify down, 6 squared would give us 36, plus 7 squared would give us 49. We're looking for our c value. Adding 36 and 49 together, we'll get 85 is going to be equal to our c squared value. Now to get c by itself, we've talked about in past units that the square root and the square undo each other. So if I square root c squared, I would be left with just c. But whatever I do to one side, I have to do the other. And so I'll square root the left side as well and end up with the square root of 85. And we had seen this when we had solved quadratic equations in our last unit using square roots. One thing we talked about in that unit was that we should get a plus or minus anytime we apply a square root. We have to think about the context of the problem. That's still true, but in this context, we're looking for a length of a side of a triangle. And since a length of a side of a triangle can never be negative, there's no need to have the plus or minus. We only get one answer, and it is the positive answer. So for this first example, our missing side length, which is our hypotenuse, would be equal to the square root of 85. Now the square root of 85 is not going to reduce down anymore, since if we do a factor tree on 85, we would get 5 and 17, and those are both prime numbers. But if we could simplify the square root down, we would want to simplify those. Let's look at our next example. So in example 2, they gave us a triangle here. The vertical side has the question mark, the horizontal side says it has a length 12, and the diagonal side says it has a length of 15. Which one of these is the hypotenuse? So the hypotenuse this time is the 15. So that's our c value. So that's our diagonal angle. It's always opposite the 90 degrees. My two legs is what I'm looking for. So my a is what I'm solving for this time, and my b value is 12. So if we start with the Pythagorean theorem, we have a squared plus b squared equals c squared. Why don't you guys pause the video and substitute in our given information? So we check this, we're looking for a, so I still have a squared plus our b value is going to be 12. So I have 12 squared plus our c value this time is 15. So we end up with a squared plus 12 squared equals 15 squared. Simplifying down, 12 squared would be 12 times 12, which would give us 144, and 15 squared would be 15 times 15, which would give us 225. To get a by itself this time, I'm going to subtract 144 over, so I'll end up with a squared equals 81. Now to get a by itself, we're going to need to square root, since the square root and the square cancel, leaving us with a. But whatever we do to one side, we need to do to the other. So we end up with a equaling the square root of 81. Technically, we do get the plus or minus, but since we're looking for a length of a side of a triangle, our only answer that it could be would be the positive one. And now we want to think about if we can simplify this down. Can we simplify down the square root of 81 any further? So in this case, we can't. 81 is a perfect square, and the square root of 81 would leave us with 9. So our length of this side that was missing for this triangle was a equals 9. Let's look at our third example. So in this example, we have a vertical side of 3, a horizontal side that has the question mark, and a diagonal side that has the 9. Which one of these is the hypotenuse? So the hypotenuse is the side opposite that 90-degree angle. So our hypotenuse value here is 9. I'm going to use our 3 to be our a value, and our question mark this time is our b value. So if we start with the Pythagorean theorem, we get a squared plus b squared equals c squared. It's our Pythagorean theorem. Why don't you guys pause the video, substitute in, and then solve for what your missing side value of b is. Let's check this one together. So we're subbing in a for 3 for a, so we get 3 squared, plus I'm looking for b, so I get plus b squared still, equals, in place of c, we're going to substitute in 9 to get 9 squared. Simplifying this down, 3 squared would give us 9. I still have the b squared, and then 9 squared would be 9 times 9, which would give us 81. To get b by itself this time, I'm going to subtract 9 over, so we get b squared equals 72. Then to isolate and get b by itself, I need to apply a square root. Whatever I do to one side, I have to do the other to keep the equation balanced. So we end up with b equals the square root of 72. Can we simplify this down any further? So in this case, we can. If I factor 72, I'm going to go over here to the left so I have some space. 72, I'm looking for perfect factors inside of it, and I'm looking for the largest perfect factor. And 72 is actually divisible by 36, and it would be 36 and 2. 36 then is a perfect square, so I can break this apart as the square root of 36 times the square root of 2, and the square root of 36 will reduce down to be 6. So our final answer here we end up with is 6 times the square root of 2. So again, we just want to make sure our answer is fully simplified, so if we have any perfect squares inside, we're going to be simplifying those down. And in our next section, actually, we're going to look at how can I simplify square roots if I have some variables inside. So we're going to continue to build off of this idea. We have one last example in this video. So in example 4, we have a vertical side of 5, a horizontal side that they've labeled as a question mark, and this diagonal side, which they gave us a value for 13. Which one of these is representing the hypotenuse? So in this example, remember our hypotenuse is always opposite the 90-degree angle, so our hypotenuse value will be the 13. If we start with the Pythagorean theorem, we have a squared plus b squared equals c squared, and now we're going to substitute in the values. It doesn't matter which ones we label as a and b, just to keep it consistent, I've been labeling a as the vertical side and b as the horizontal side, but it actually doesn't matter. They're both legs of triangles, and so we could technically flip-flop the a and the b and still get the correct answer. Why don't you guys pause the video and solve this one out on your own first? Let's check example 4 together. So example 4, our a is going to be 5, so I'll have 5 squared plus, we're looking for the b squared value, equals, our c is going to be 13, so we end up with 13 squared. Simplifying down, 5 squared gives us 25, plus b squared equals 13 squared is 169. To get b by itself, let's subtract the 25 over, so we get b squared equals 144. Then to isolate and get b by itself, because remember our goal is to solve for the length of the side, not the square of that number, I have to square root it so that the square and the square root cancel. So I also have to do that to the other side. We're just looking for the positive answer since this is representing a side length. So we end up with b equals the square root of 144. This can also be simplified down further. 144 is actually 12 squared. So 144 factors as 12 times 12. So the square root of 144 then would be positive 12. And that will be our final answer for example 4. As I said a little bit earlier, we are going to continue to build off of this and introduce other things and simplifying square roots. And we're going to not only have numbers inside of our square roots to simplify like we've had in these problems, but we're also going to introduce variables into our next section for how we can simplify in Learning Target 10b. And then in Learning Target 10c, we're going to bring back equations and we're going to work on solving radical equations. So this was a little introduction into Unit 10. And so Unit 10a was all about using the Pythagorean Theorem and kind of seeing an application of how we can use square roots to end up solving problems and simplifying our answers down.